All right, now we know that not all data is going to be symmetrical and bell-shaped. So there is a separate theorem called Chebyshev's theorem that allows you to figure out percentages that are appropriate for a skewed data set. So I want to remind you that a skewed data set is somewhat bell-shaped, but it's lopsided to one side. So there's an example of skewed left, because the tail is on the left, or we could see skewed right, okay? So this theorem is applicable for these types of data sets, all right? So the theorem states that at least, and then there's a formula, 1 minus 1 over k squared times 100% of the data values. And don't worry about that formula, you will not have to memorize it. Lie within k standard deviations. Whoops. Let me fix that. It slid on me. Of the mean. Which again is x bar. Okay. All right, so let's give that a little bit more context. So if k equals 2, 1 minus 1 over 2 squared, 1 minus 1/4 is 3/4. So that's at least 75% of the data values lie within x bar minus 2s and x bar plus 2s, within 2 standard deviations of the mean, okay? So instead of being 95% of the data is there, we get to say that it's at least not 75%. And oftentimes it's more than the 75%, but we don't know for sure. It depends on how varied the data is, all right? If we do k equals 3, that would be at least, it would be 1 minus 1 over 9, because that's 3 squared. 8/9 is 89% would lie within 3 standard deviations. X bar minus 3s and x bar plus 3s. Now we're going to stick with using 2 standard deviations. Anytime we calculate typical min or max, we're going to use 2 standard deviations. We're going to use the x bar minus 2s and the x bar plus 2s whenever we're doing anything considered typical, because at least 75% of the data, that's still a significant chunk. It's more than a majority, so that's what we're going to go with, okay? So this data set right here, when we take a look at it, this is the skewed data set. If you were to turn it sideways, which I can't do for you, but if we kind of trace this, we can see it's got that skewed shape to it, okay? So Chebyshev's theorem applies to this particular one, but we're still just going to figure out typical, minimum, and maximum, all right? So I went through and I found the mean and the standard deviation using a graph and calculator. I encourage you to pause the video, take a minute, and practice finding the mean and standard deviation. I want to remind you that when you see this, that's equal to the number 50. And then the 5 with the 2 next to it is 52. The next number is 68. And then I've got 74, 79, 79, and so on, okay? So that's how you input the data into the calculator. These are all double-digit numbers because they're test scores, okay? So you need to be able to read this stem and leaf plot to type all your numbers in. But x bar ends up being 82.9 after rounding. And then S comes out to 12.7. So if I wanted to figure out my typical minimum and maximum values, all right, so I'm going to figure out my typical minimum first using x bar minus 2 standard deviations. So x bar is 82.9. Take away 2 times the standard deviation of 12.7. All right, and that comes out to 57.5. Okay, and then if I figure out my typical maximum, using the same formula but with addition instead, I'm going to get x bar plus 2 standard deviations is 82.9 plus 2 times 12.7. Let's squeeze it in there. There we go. And that computation comes out to 108.3. So that means anything between 57.5 and 108.3 is considered a typical test score for this particular class or this data set. Anything smaller than 57.5 is going to be unusually low, and anything bigger than 108.3 is unusually high. So looking at my data values, I do have some outliers here. So when I take a look at this, the 50 and the 52, those are unusually low because they are below the 57.5. Okay, so there are two unusually low data values. The 50 and the 52 are unusually low. Okay, there are no unusually high data values. Because there's nothing above 108.3. Our largest data value is 98. Oops, 108.3, Miss Mara. There we go. All right. So you need to be able to use a graphing calculator to find mean, median, and standard deviation now. And you need to be able to find your typical minimum and maximum values so that you can determine if you have unusually high data values, unusually low data values, or just typical data values. All right, that's the crux of what you need to know. Let me know if you have any questions.